Hello, my name is Guiomar. I work for Universidade Federal Fluminense in Brazil. The title of my work here is Linear New Approach for Trigonometric Inverse Series Applied to Newton-Raphson Method, present in 23rd CIMPA Costa Rica, February 2022. Okay, the motivation. I found this paper by Kumar, Tota e Kumar too. Title is a new trigonometrical algorithm for computing real root of nonlinear transcendental equations. So based on this work, I observe that the new proposed algorithm is based on the combination of inverse of sine series and Newton-Raphson method. The observation was that not only the sine series and is possible to rewrite the Newton-Raphson method. The purpose of this article is to show that not only can the inverse series of sines be used to approximate the Newton-Raphson method, but also the inverse series of the tangent as well as the hyperbolic sine and the hyperbolic tangent too. Thus, these representations result in a new approach to simulate the Newton-Raphson method as approximation through a linear interpolation function, so we can rewrite the Newton-Raphson method. And numerical simulations show that the present proposal provides excellent numerical results. So the trigonometric inverse series can be used to represent this important relation in the method given by the inverse function of tangent, for example. We call equation 1. Expanding the inverse tangent function in power series in this iterative formula, the formula presented before, equation 1, we are able to obtain the standard Newton-Raphson method. Let's state the following theorem. So this theorem can help us to understand and of course to develop the power series based on Taylor development for the functions. So the functions, the inverse sines and the inverse tangent are written as we can see. The validation for this development is in the closed interval between -1 and +1. So if we plot the two functions, the inverse tangent and the inverse sinus function, we can see a very narrow interval between -0.4 and +0.4, which have a very similar behavior. And as we observe the figure 1, that in the narrow interval, as we said before, the two series has a similar behavior, showing that there is a numerical gap between the two, since they are not the same. They are not the same, but they have a very similar behavior, and also show us they have a linear behavior in this interval. The relation in the iterative process, as I showed before, tend to zero in order to work the Newton-Raphson method. So it's possible to fit a first-order polynomial to each curve in the interval minus 0.4 to plus 0.4, and rewrite the equation 1s. So this is the last version of our proposal method, where the parameters a and b are fitted by least square method, as we can see, a, b for sinus series and inverse sinus series, and also for inverse tangent series. So these are the parameters for the both development. So those are the reference, the partial reference list used, and I thank you. Obrigado.